fifth edition is touch. So let's start with the development tool list that will be required for a Symbian application development. Uh, so development tools like third edition SDK. Here are the links for the third edition SDK. Links are quite huge, so I made a tiny of it. Uh, uh, the third edition SDK link and the fifth edition SDK link, along with these are the SDK which will be required, which will provide compilers, Symbian utility tools uh, for Symbian development, and uh, uh, when you will install these SDKs, you will require the application. The SDK will ask for active Perl download. So there is another link mentioned for active Perl, and then there is a Carbide C++ ID which is written on top of Eclipse, and it's like an Eclipse but for Carbide C++ development. So here's the link for the same. This diagram shows where the Symbian OS SDK lies. So I will be having this is my Windows machine, which and this is my Symbian OS SDK, which provides me a device simulator, so that I can develop locally on my simulator and verify my applications. It provides compilers. It provides APIs and libraries for target and emulator, and the Symbian generic build system, which helps us creating the final output file, which we run on emulator or the device, and this complete block connects to a smartphone, and either you can send this executable onto smartphone directly, or this SDK also provides a way to phone debug the application. So now let's start with the simple hello world program. Assuming you have downloaded or you will download the SDKs required. So it's very simple to create a hello world program. You actually, by default, if you create any project inside a Symbian application, it will automatically it will automatically show a note. So a default program is hello world. So what you do is you just need to launch Carbide ID and follow steps. So let's follow them. I switch to this and I launch my Carbide. So here is my Carbide C++, the ID. This will be initial screen of my Carbide. So I closed it. Now I need to create a new project. So I have launched the Carbide ID, and now I go to File, New, Symbian OS C++ project. Okay, so here I will choose S60 GUI application. So S60 and GUI application. So I do next. I put a name hello world to my program. Do next. Now it will ask for which, see, so like I mentioned that there are two versions of SDKs, like for third and fifth edition, which is for non-touch and touch devices respectively. So I have installed both the SDKs on my phone. So while creating my project, it asks for which SDK I want to use, which application, which platform I want to target. So I choose for non-touch devices. So I choose uh, emulator debug. Because I want to develop application on for I want to test it on emulator. So I just choose emulator debug. Then I do a next. It prompts for a basic information box. So your application, you must be ready with your application. uh, so I change my author. It's not required, it will pick a default name. So author, apart from author, there is a field called UID. So this UID is a unique, as the name suggests, is a unique identification number, which will be generated automatically by the Carbide ID. But in case you choose to deploy application on OV portal, which is then you have to take a releasable UID from the Symbian site. So this is, it's my test application. I can't release my application to the market using this UID. And I do a next, and then I do a finish. So my hello world program has been generated. Let's see what is in there. It have include, which is, if you see, then it's so I have installed my SDK, third edition SDK, into this folder. So it's system include, it's just shown over here. It's having many files, like set of header files has been generated, set of source files been generated, and rest of them I will cover. So now you can see that there are 5 header files, 5 CPP files, and these 4 header files are generated. So what do they have? So let's switch back to my presentation. So now we will discuss the application components. So in any of the Symbian app, following some classes will always be present. Like the first class, which is written over here, is the application view. So you can see that in the source folder and in the header inc folder will have include files. So I am having hello world app view.cpp and the corresponding header file hello world app view.h. So this is the first application component of my hello world application. This class is as the name suggests, it's view.cpp. So this class will take care of the UI part, and if you have to draw anything on your screen, so then you have to use this appview.cpp class. And if your application is having multiple controls, then it can have those controls inside it as well. So if I go to header file for this class, then you can see that this hello world app view inherits a Symbian defined class CCOE control. So this is typical Symbian class, which provides a way of writing onto the screen. So it's a view class. Okay. Similarly, like view stands for view. So there is another application component is application UI, which creates view and handles the command sent from application's UI control. So if I go into UI.cpp, then you can see that this class will be creating view object. So this is automatically generated is stuff that will be there when you create a new project. So this class is creating an object of a view instance. Okay, don't go into this new L things. We will discuss it later. So this UI class instantiates view class, and every key activity which will be sent to my application will be uh, which be handled by UI, first handled by UI class. Okay, so UI class is the entry point for our application inputs. Now let's talk about other application components which are there is a class called hello world document. In document class, it's a normal MVC structure. So document class is for having non UI data for application. So but it's a recommendation, it's not a must. So you can have your data inside any of the classes for that matter, but uh, it's uh, it's a designer's choice that you can take. So this handles non-UI data aspect of application and instantiate UI class. So you can see that inside the document classes constructor, this function will be called inside the constructor. uh, we are having we are creating UI object for this application, and inside, and as we have already discussed, inside the UI object we will create a view for the application. So we have discussed UI, view and document. Then the last part is application. This application is a main class, uh, Hangman hello world application, and this will create the document class. This will instantiate document class. So it's just used for instantiating. It's initial choice that they make, and then the last class which is the entry point for the application. It's uh, where we create application class. So it's a E32 main, like a normal main in there is there in C++. In Symbian C++ is E32 main, and it invokes new application, which invokes hello world application, which invokes document constructor, which in turn invokes UI constructor, and then finally the view constructor is made. So before let's run this hello world program, which is automatically generated. So I have created this hello world project, and now I will uh, I do a build run Symbian OS application. So now it asks for me for which process should I launch. So it is asking this exe is generated during the build process. So I can choose to launch this exe, but the problem but it's not recommended, because when I will close the application, this exe will be closed and the emulator will be closed. So if I choose emulator is to be processed to be launched, then I don't need to re-invoke in emulator to relaunch the app. So I do a finish. Excuse me. So my emulator is it's slow. Uh, that's why we prefer not to launch emulator every time we do a change in application. That's why we have uh, process to launch. We have chosen emulator, not the application.exe. So So it's yeah. So let's build this project. So I, like a typical Eclipse plugin, I do a build project. It's building emulator debug. So on doing this build, that particular hello world.exe will be generated. Actually, the name is not hello world.exe, it's hello world underscore uid.exe. Now I can go to installation. This is the typical look of a Symbian emulator. Over there, various options are there. You can see the current screen size is 240 cross 320, and there are various other things that are provided with this tool, like for example, this you can track your memory of the application. So current memory is this, and this is the initial memory that this application requires, and you can see whether there is a memory leakage or something using these diagnostic tools, the driver and the CPU. So all can be, you can see all that stuff. So now I go to installation, and there is a hello world, and I guess it's this one. This is hello world, my hello world program. I launched it. I can see a blank screen, and there is an option menu. So I click on option menu, I click on a message, and I can see the hello world text. So this program is automatically generated when you do a when you create a new project. So now let's understand the automatically generated files to some extent, and for that we require basic knowledge of Symbian data types. So let's cover that. So like all other language provides int, char, bool, Symbian also provides the same set of data types. You can use int, but to ensure machine independence. What is machine independence? Because Symbian is an interface in OS, and OEMs are free, like HP or like Sony Ericsson, Nokia, are free to choose its implementation from handset to handset basis. So you can have you can't ensure that int is of same size or same bytes on different platforms, on different handsets. So what Symbian has done, they have provided their own data types which are machine independent, which guarantees machine independence. So like for example, here is a tint. Tint is a generic data type for int. Tuint is generic data type of unsigned int. Tint8 is generic data type for int with 8-bit length. Okay. So now Symbian, when you will see a Symbian code, or we will see the auto-generated code, Symbian has a naming convention in their classes. So in classes name, so the classes which starts from T, so which are known as T classes, are data type classes. So like we have just seen Tint8, so tchar, these are data type classes. Wrapper for data type class. The classes which start from C are the classes which are derived from a common parent, which is C base. What is C base? So C base is a Symbian implemented class which have a virtual destructor and various other usage which we'll discuss soon. So using seek-based classes, uh, uh, these seek-based classes or class objects are typically allocated using heap. So you will do a new on that class for to get an instance of that object. You won't typically create this object on a stack. Why? Because C base class has a virtual destructor. So uh, we will see the things in detail, but uh, using C base derivation, it ensures that the all data members are initialized to 0 when it's allocated on heap, and at the time of destroying, as C base is having virtual destructor, all the destructor of the derived class is called. So this is C base class. Now then there is a R classes. R classes is resource classes. So resource class is something like you can delete a resource object, but it's not necessary that the the resource it actually points to is deleted. So resource class contains handle. So you can see they are normally allocated on a stack, and these instances are to handle resources. Uh, so and they contain the handle of the actual resource inside the platform. So if you open a file, so then resource class is not is a like pointer to file. So typically resource classes have a function to acquire the resource and then to release the resources. So most of the resource classes, not all, but most of them contains an open method and close method which opens or close the handle to that resource. So the examples are like file, R file, and R thread. So you open a file, you close the file, and you create them on the stack. Then there are the last set of classes, which are M classes. These are interfaces that like callback methods which are implemented by your classes, and so these are interfaces classes. M stands for mixin. So this is M classes. Now let's talk about exception handling in Symbian. So in Symbian, like in typically now in C++, there is a try catch handling, but at the time when Symbian was written, there was no try and catch available on C++. So they came out with their own ways of error handling. So first of them are many of the functions that you do to do some stuff, like for example a file open. So file open will return a integer that is int. So and you can check it with Symbian provided uh, standard codes like kerr none, kerr no memory, which you can use to see whether there has been a error while doing this stuff, like while opening this file, if there is an error, that means file is not present. So first way is by return values of a function. The other way is, which is same as try catch, is leaf trap mechanism. So here try catch block, uh, try block is trap. So here is an example. I have done a I have uh, I have defined a integer t int leave error equal to 0. Then I call a function. I do a trap and I pass it this integer reference, and I call my function. So if there is any exception inside this my function L, then the exception will be thrown, and we have an exception object in try block, we will be having exception error code in this leave error variable if there is an exception. Otherwise this leave error will be same as 0. So on the next line I can check if leave error is 0, then I have done successful stuff, and if leave error is non-zero, then there is some issue with my function L. Symbian Symbian typically Symbian is having uses L suffix to denote a function that might leave. So it's effectively a definition. If you have used Java, then it's like throws exception. So this function might leave. So if I have used if there is a Symbian class or API that you know, and you see that there is a suffix L with that API, then you know that this function can leave, and then you have to handle this trap. So as happens with try and catch, if my function L calls my function 2, then the trap and my function 2 call is not trapped, then I will get the trap on the topmost level. So now there is a logic of cleanup. So this till this point we were talking about exception handling like try and catch block, but now let's discuss about the cleanup task. Cleanup stack is something that you push on to the main stack, push some variable which you have created on a heap, and then you pass it, you push this variable onto the stack and you do some stuff. If there is a problem doing that stuff like a particular function call, then and then function leaves, then automatically this at the time function will leave, that object is destroyed. So you don't need to handle it explicitly in the code. So let's see this example. Like I have a C derived class. Yes, this is extension C. Okay, so it will be created on heap. It has for its proper usage. So it's created on heap. Then I push this object, my object, to the cleanup stack. Like cleanup stack colon push L my object. Then I created another set of another heap object, and then I push that object also onto the cleanup stack. Then I have done some stuff, and I have written cleanup stack pop2. So what will happen if do something L run successfully? Nothing will happen. These two items will be popped from stack, and then they will be destroyed. But in case do something L leaves, then these objects will then these lines won't be executed because this function leaves. So these because these objects are present on cleanup stack, they will be automatically deleted, and deleted with a proper deletion like destructor call and so on. So let's now see the hello world program that was generated by the Carbide. So like for example, I go to view class. So this is view.cpp. Now you can see this is view constructor which is blank. Okay, and then there is a function newL. Symbian automatically generated code has a tendency newL and newlc are another way of creating an object. So like I go to UI class where this view is instantiated. In UI, let me go to, yeah. So my view object has been created using this static call newL and the arguments. So this is called two-phased construction in Symbian. So what will happen? This so this because there is an L, that means this function can leave. So this function can leave. So I go to inside this function. This function call another function which is the new LC of the same class with the same arguments which are passed to the to new L, and this new LC creates this the actual object of this class, and then push it onto the cleanup stack, and then call a construct function which is a leaving function. So any error which occurs during this point is automatically handled because the object has been pushed onto the cleanup stack. And after this call finishes the new LC, then we pop this object from the cleanup stack. So basically it's a simple way of construction, but just to ensure that function don't leave, the constructor don't leave, we use this two-phased constructor approach. And actually we don't require it if we are sure that that our constructor won't leave. So you can see that in a simple hello world program you have to be clear about this cleanup stack concept and the cleanup stack concept and the trap things. Now let's go back to our slide. And so we have talked about view class. So in view class we have a function draw which will be automatically generated. So like I can see this is my view class, and this hello world view will draw. This is the rect which is passed at the time of construction object construction, and this basically have the drawable area. Like we are running it on emulator of 240 cross 320. So this rect will be having those dimensions. So what I do inside, we have seen that when we run the hello world program, so there is a blank screen. So because now we see what code it has generated for us. It has created graphics context, and then it uses the rect API returns a device dimension rectangle. So and then we have done graphics context dot clear the specified rect. So that is why the window is blank, because it's been clean. So let's fill some stuff onto this screen. So let me modify this draw so that I can see my things in this program. So what should I do? So let's let's in this example let's fill the screen. So what I will do is I will do gc dot set brush color. You can define your own color, but there are some colors which are provided. So let's do this brush color blue. brush style. Shed brush style is graphics context. Solid brush is complete fill. You guys, I guess, who developed the application on another platforms will be aware of it. So now I do gc.drawRect. So drawRect requires a rectangle. So rectangle has many constructors. So I choose direct, and the arguments are, so it has many arguments. So I choose this constructor which takes first argument as the starting point, which let's say my screen size is 240 cross 320. So let's choose the starting point as 10 20, is the x coordinate 10 and y 20, and the size of the rectangle to be painted is t size, which is, let's say, it's width is 220 because the dimension is 240 and height is 50. So I do this and I do a build project. Okay, so now I can see the output. Hello world. So uh, it uses color blue. uh, the uh, the brush style to fill this rectangle is solid brush, so there is no gaps inside it. There are many other brush styles which you can see in using this complete enum. You can try it out, and these are the rectangle coordinates. So I have created a rectangle. Let's try to add one new rectangle with using this. So what I do is I simply copy this stuff. So let me change the color to, let's say, red. Okay, RGB red. Let's change the coordinates. So coordinate is 100 and size is same. So let's compile it again. Now I can see that installation lower. So now I have two rectangles, for one for blue rectangle, and then the other one is because the coordinates are different. So I can, if I choose the same coordinates, then the later one will be applied. Okay, so now it's basic drawing stuff, and let's say I want to write a text also. So for that also you can explore this window GC class, and you can see all the APIs starting from the image painting to text drawing. All you can do using it. So for text drawing you have to specify font. So I will use I will use a system font, which I know is available over here, but you can create your own fonts. There are APIs you can explore in the Carbide help as well. So I say use this font. Like text, like there is a string in Java, there is a literal terminology defined. So I create a literal, which is essentially a string. So my string, okay, my str, and I defined this hyphens. Okay, and then I use GC because I have to draw text. So then I explore draw text. I have to pass the string, okay, the literal. the k minus tr and the points, the coordinates t point. Let me give the starting end for this point to show, because we if you use any font, then it's your responsibility to free it. So you have to call discard font API if you have used. So let's draw this, and now I run the hello world program and I can see this. Hi friends. Okay, so this is basic UI drawing. Now let's talk about the event handling. So like I have said that UI class is for event handling, and this is the view associated with this UI. So then I have to pass I have to tell UI to send events to this particular view. So what is done is Symbian does event handling using, let's talk about this. So control stack mechanism. In this you push a particular view onto a stack, and which view is pushed onto a stack, that will receive the events. If there are more than one views on a stack, then starting from the lowest view, which will be pushed first, those views will, in that order, views will get the events. So to add a view onto stack, there is a API in UI class add to stack. So what I will do is, in UI class where I have created a view constructor, I will do a add to stack, and I will pass the view, the I app view. Okay, and since I have added it at the time of construction, I have to ensure, otherwise this program will error out, will panic at the time of exit. I have to remove it from the stack as well. So I will do a remove from stack, and I have view. So if I have added, so by this thing we have specified that events for this UI should pass events onto the view, my view. So to handle those events, I have to write event handling hook. So like for in control class, in view class, I have to define this function. So what I will do is I will copy it, or let's do this in the view class. View, first go to the view header file. This is function that I will overwrite. So I will do key response. I know the data type, so otherwise you can consult the help. So what I will do is copy it. So I have created this, and inside this key event handling, so when I press a key, so when I press, for example, this one, so I will be pressing it, and yeah, 5 minutes. So I will be pressing it, and then I will be releasing it. So let's do it quickly. So event will be for key down and key up. So let's 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 choose to write it down. So what I will do, because of shortage of time, I will show you the new other program which I have already created for you guys. So this is the other hello world, and in this I have written UI logic. Oh, sorry, view the logic of key event handling, key event down, and the scan code. I've seen the scan code of the keys, and depending on that, I have changed my state variable, and this state variable is used to select the color of my my rectangles. So final look is this. So if I do a key down, this color changes. I do a key down, this color changes, and then nothing has been. And if I do a key up, then it's like a focus. So that's a basic key handling. So guys, I guess we are up.